Right, we're going to kick off this afternoon. My name's Giles Gibson. I'm one of the volunteers on the Hernhill Forum who put this whole series of seminars together. Really wonderful that you've all managed to give up on Sunday afternoons to come up here. Got a few boring things to start off with on the safety. Fire exits through the door there, or exit where you came in, and the toilets are through there. There are no planned fire drills for we're going to be filming this afternoon for a very popular YouTube channel. All these seminars are filmed and edited up. And thanks to Ed at the back who's doing the camera. So best behaviour, everyone. Remember the smile, all those kind of things. It'll be good. So these series of 4 seminars that we've been running, they're all about helping people to reduce their energy bills, reduce their energy use, and reduce their carbon footprint. Really important. We're in this building, we booked this one deliberately because I don't think many people know about Brockwell Barn. These greenhouses and the area used to be run by the London County Council, and they used to grow all the bedding plants for all the councils in London. They used to come from Brockwell Park, all the roundabouts and the verges and things like that, and have the little plants all grown here. Then it went into disuse and it became very derelict and run down and overgrown. A few people, local volunteers, decided they wanted to turn it around and do something with the space. And they took it on and they have repaired all the beds, they've replanted, they've repaired the greenhouses, they're starting an amazing series of what they grow. On the, even though they've got sensory garden, they sell their produce, they've got the shop going. They do classes here, they do events in the greenhouses, musical events, film, educational, all those kind of things. And they've raised the money to build this barn. It's just phenomenal what happens when a few local people, volunteers, don't put up with the fact that it's broken and can't be fixed. They got in and they did something. It's a tribute to all their effort over the years, what they've achieved. So this afternoon is all about heat and energy sources. The first half will be about heat pumps. Those are fridges that work backwards. So now you know that's the technical stuff done. Air source and ground source will be the main ones that we're going to cover. So they're extracting the heat and delivering it into your home. The second half is all about solar, what works, what doesn't, batteries, and hopefully we're going to have to talk about community solar projects. After that, we'll have a chance for a cup of tea, a few nibbles, opportunity to chat with all the experts that we've got, along with other residents who are going down the same journey on looking at how they can change where they live to improve the heat and the energy efficiency. So, to kick off this afternoon, we've got this session about heat pumps and boilers. Let's set the scene. The Climate Change Committee scenario for meeting net zero meant that we would need 27.2 million heat pumps by the year 2050 in this country. There are a few government subsidies for heat pumps, but at the current rate of installation, given that we've got 26 years, how long do you think it would take, current rate of installation, to meet those Climate Change Committee targets? Any ideas?
100 years?
100 years?
200.
200 years? Think about the current government. It's about 600 years. But we're not really hitting it very well. We're meant to be doing 15.3 installations per 1,000 households. And at the moment, the European Heat Pump Association has said that the UK is at the bottom of the European league for heat pump installation. We are just doing 1.48 heat pumps installed per 1,000 households. And those nasty Norwegians are doing 49.7 installations per 1,000. So they're at the top of the leaderboard. We only put in about 42,000 heat pumps last year, and we're meant to have a target of 600,000. So we're that far adrift. So, to explain what it's all about, could you please welcome Alfie and Paul Dunk, run a family firm called BB Heat Pumps. They're local and they're experts in air source heat pumps, underfloor heating, and heating system design. And they're MCS certified. So all those people who were at the Carnegie Library, you know all about MCS certification and why it's important. And then they'll be joined by David Rowden from Flujo, who is into boilers. It's his passion in life. He takes installation manuals on holiday for reading material, you know, the classic Dickens novel, you know, David Copperfield. And they're often seen going around Herne Hill doing installation. So if you could, whoever's first, come up. Yes, that'd be lovely.
Can you hear me? Great. Well, good afternoon, and thank you, Giles and Yazia, for inviting us to here today. So I'm going to talk more generally about heating in our homes and go forward in the future, and then Alfie's going to follow on afterwards and be a bit more specific about heat pumps. We've got Jolene who's going to join us later, who's going to be talking about EPCs as well, which will be relevant to the point. Okay. Anyone? It's always a good start. Okay, so a little bit about me. Yes, Flujo, you may have seen our vans running around. I've lived in SE24 for over 20 years. My kids went to Rosendale, and now at Elm Green, so we're very much a local company. I apologise if we blocked in any of your driveways. So I'm a gas safe engineer, and although there's to some people it's just an expensive plumber, actually, you know, for gas we have to be retrained every 5 years. And compared to commercial airline pilots, they're the only career which is more tested than us. So I'd like to think you're in safe hands with us. We're not only repairing things, we're also doing safety, efficiency, I want to save you costs. Personally, I've been trained and I'm an approved installer for Beastman, Baden, Worcester and Atte. They're premium brands of boilers. I'm a Heat Geek approved installer, passed their very testing exams, and I've done their heating academy up in North. So let's see where have we come from and where we're going. So really, for the last sort of millions of years, ever since, we've been burning wood. And we're burning coal for about the last 4,000 years. Then we, in the UK certainly, since natural gas came in from the North Sea, since about 1967, we've been burning gas. Now what's heading off into the future? Now, we can't keep doing this. We keep digging things out of the ground and polluting our atmosphere. So where are we going to go forward with this? So, problems with the present. Natural gas is 90% methane, but natural gas sounds a lot nicer than methane. That's why we tend to use it. It's CH4, so 1 carbon, 4 hydrogens. It's colourless, odourless, highly flammable. Might surprise you that methane is odourless, but we'll put that in a bit more. And when you burn it, you get heat, water, you get the emissions, you get the carbon dioxide as well. So currently, as Giles alluded to, we've got about 22 million homes with gas boilers in, and they produce 58 million tonnes of CO2 annually. That's more than the cars, basically. I think we've got 26 million cars, and they do 56 million CO2 tonnes annually. So a lot of energy and time is put into decarbonising cars, not enough into heating in our homes. Here you can see, so the colourant has been added to methane at the top. That's a current boiler. It's blue. You can see the mix down the left where we start adding hydrogen into the mix, and this is a hydrogen flame here, which is orange. These are the colours that we added, so it'll be different. So, what are the government proposals and actions? Well, inaction, generally, but no, you won't have to get rid of your boiler. I get asked lots of times, have I got to get rid of my boiler in the next 2 years? Not really. So, in 2025, low carbon heating going to all new homes. And the plan is, and it's a movable feast, inevitably, 2035 to be a ban on high carbon gas boilers. Now, high carbon currently is natural gas. About 10% of your boiler emissions are CO2 going out the flue into outside. We measure that when we do testing and efficiency, and 10% is actually how it's meant to be from the manufacturers. Can't really bring it down much more than that. So, what are the government proposing? Low carbon, low temperature alternatives, hydrogen and electricity. Hydrogen's had some noise in use, which has been great. What are the positives from it? Well, so at point of use, when we burn it, has no carbon dioxide at all. It only produces heat and water when burnt. It's great. It's already a gas at room temperature, and we can use existing fibre and grid lines coming into our houses. So no new infrastructure, particularly at that point. But the negatives, well, it's colourless and odourless. We've got to colour it, we've got to put a smell in it so we know where it is and where it's coming from. H2 is hydrogen, that's the chemical compound for it. It's the smallest and lightest compound. That makes it, if there's a hole in your pipework or a leak, CH4, methane, we saw earlier, that won't find leaks, but H2 might do. So we've got to be extra safety conscious about H2. It's very inefficient to produce. We're going to go into that in a minute. And if you could put methane and hydrogen in a race, hydrogen is 3 times faster than methane. It actually races off into the distance. It's a very fast flame, very difficult to control from us as a boiler installers and from the manufacturer's side. It's also got a wider flammability range. So you, unlike Barney and Stallone, you can't ignite neat methane. It just doesn't work like that. It only burns within 5-15%. If it's wider environment of air, it needs oxygen to burn. So that's quite a tight window, 5 and 15% of the environment. Hydrogen will burn anywhere between 5 and 85% of this environment. Much wider flammability. Again, safety concerns, we've got to be quite careful with it. And it can corrode iron. Now, most of us have got iron in our pipework leading into our house at some point. And the estimated upgrade for that is £40 billion to take that iron out. What research has happened so far? But Keele University, they're very lucky, they've got their own gas supply, and there's been tests going on with a 20% blend of hydrogen into the methane. Now that they've worked that out, if they can put that down into our pipework, ignoring the 40 billion cost, 6 billion tonnes of CO2 can be saved. That's equivalent to about 2.5 million cars off the road. It's a good saving. It's less than 10%, but they're going to do it in stage. 20% hydrogen before they even think about doing 100% hydrogen 10 years down the line, at least. How do we make hydrogen? Okay, 4 different ways. Black hydrogen, burning coal, and then capturing the hydrogen off there. Obviously, terrible idea. We don't want to be burning coal. It's awful idea. Then we've got grey hydrogen, burning natural gas, and then capturing off there. We're still burning gas. Awful idea as well. Next one is blue hydrogen. So it's still burning gas. Some people are still making money out of us buying gas, but we're carbon capturing most of the carbon dioxide, not all of it. It's very expensive. Because what do we do with that carbon dioxide when we've got it? Nobody's really worked out what we're going to do with that yet. The real way to do it is green hydrogen. From renewables, solar, hydro, wind. Much better way to do it. But it's 80% efficient. It's not very efficient. Hydrogen boilers are only 80-90% efficient anyway. You can see we're starting to get losses with the system already. How much energy do we need in the UK? So domestic heating, this is 2020 figures. If I say now, I need 2020 figures. Currently, 2020, 270 terawatt hours of heating we need. It's quite a lot. So if we were going to produce hydrogen from renewables, because of the inefficiencies, we're going to need 370 terawatt hours of energy. Now, power from renewables currently, 2020, we only make 120 terawatt hours of energy from renewable sources. We're way off it, nowhere near it to be able to do that. We'd have to make that difference with gas or coal. But heat pumps are very efficient, 350% efficient. And if we could put all our energy into there from renewable sources, as a country, in 2020, we'd only need 90 terawatt hours. You can see the difference in the graph. So, do we want renewables to make hydrogen, lots of processing, lots of losses into our home? No. Might as well just pipe it straight in with electricity into your heat pump. 2 different types. We've got air source heat pumps with the fan units. Alfred's going to talk more about that. And then we've got ground source. We've got 2 different types. We've got the vertical boreholes and we've got horizontal arrays. So heat pump efficiency and about the amount of money that we're paying for our electricity and gas as of a couple of weeks ago. So gas we're paying a capped limit of roughly 10p a kilowatt, electricity 34p a kilowatt. So it is expensive to run anything with electricity at the moment, 30% more expensive. But if we add in heat pumps, say 350% efficient, the running costs are about the same as gas. So there, where it brings it right back in now. And that's only those differences in cost are only going to grow. How are heat pumps so efficient? Because they run at lower temperatures. You see down the bottom, we've got a standard gas boiler. Outputs flow temperatures at roughly 75 to 80 degrees. It takes a lot of energy to get up to that heat, make that energy. Heat pumps are running at a flow temperature of 45, 50 degrees. So what's the benefits of low temperature and low energy? Well, we're literally using less energy to make that heat that we need in our houses. There's thermal expansion. You'll hear pipes creaking in your house, that's thermal expansion. I don't think that's me. So less expansion, less noise. It's easier life on internal components. And less corrosion. Corrosion is a killer for heating systems. What's the negatives of high temperature? Well, you get more airflow. Now, radiators are convectors. 80% of the energy comes through the radiator, cold air at the bottom, hot air up out the top, circulates through. It's a convector. That's literally what it is. If we can have lower temperatures, it's more radiant. It comes out the side. So it's less airflow. Less airflow, it's less dust and mites. And there's an increase in asthma for kids. We have it's about 10% of kids nowadays have asthma, and it's largely put down to increased airflow throughout the house and dust and mites. Temperature aware components. If you heat anything up more, you've got this expansion, contraction, you're working everything a lot harder. And then increase in line scale inside the components, just like the inside of your kettle. Now, 1 millimetre of scale is said to, inside your heating unit or boiler, said to decrease your efficiency of your boiler by 5%. We'd all like 5% back on our bill or something to be more efficient by 5%. Efficiency in the present. So most of us now have obviously got gas boilers, as we've seen. What can we do with our current components that we have? Now, a combi boiler, there's been some news, noise about this in the news. Combi boiler runs 2 temperatures, one for hot water, one for heating. We can turn our boiler temperatures down, mimicking heat pumps. So at the box, boilers want to run at 70, 80 degrees. We saw that earlier. I've been turning my boilers down to 67 degrees, something like that, over the last few years. Do we still get the heat out of the radiators? Yes. You just turn it down. Those incremental differences of turning down your heating really can make a difference. If we had a static gas bill, at least, it's very difficult to see. So there's different things we can do there to try and immediately save you some money. Intelligent controls, these are also can help us. So at the moment, a lot of boiler controls are on or off. We like to live in a target 21, roughly, give or take. But if we have an inefficient control, you can see it ramps up there on the graph. We might turn the boiler off, but we still have heating coming into the room. So actually, it kind of varies, and we see this kind of wild swing going on. And actually, when it's off, on and off, we can see 22.5 to 19.5. That's 3 degrees difference in our actual own house. And sometimes you think, oh, I'm a bit warm, I'm a bit cold. This is because your controls aren't necessarily intelligent enough to maintain a stable temperature. If we have something a bit more intelligent, you can see in advance what 21 degrees is. It starts to ramp off. You can see that much more nicer sine wave. That's more comfortable for us in our homes. Range rating is something else. Most boilers have about 18 kilowatts of energy coming down the heating. 18 kilowatts, roughly 18 radiators. Not many of us have 18 radiators, so I suggest, in fact, most of us only have about 8 kilowatts of radiators heat. Imagine 18 kilowatts trying to come out the boiler, going down to 8. It's much like the bottleneck in a motorway here. The boiler just overheats because it can't get rid of its energy, and it does that cycling, it mimics that cycle. So turning down your boiler kilowatt rating. It's hidden in the installer menus, but you should be getting your installer or service guy to look at that, tuning your boiler to the output. Recommended controllers. These are the intelligent ones. Personally, Tado, they're excellent. They're really very good. Honeywell, it's a big mate. Evo Home, it's one of their brands, which is very good. And Nest is very popular. They also know what to link in with your bells and cameras and things like that. So, yeah. That's a roundup from me. Thank you very much for your time. Looking forward to having maybe some Q&A or informal things with you if you've got any further questions. Okay.
Got Elfie? up next. Yes,
I
sure.
won't do Dave again, that might be different.
Don't do it again.
I've got a different one.
Yeah, sorry.
Sorry, do you want to? Okay, so yeah, so going on from Dave, we're going to dive into heat pumps, renewables in a little bit more detail. So firstly, a little bit about who we are. My name's Alfie. I'm here with my dad, Paul, and our office manager, Callum. We run a heat pump company. Originally, Paul started his plumbing and heating company 30 plus years ago, long before I was even born. So he's got a lot of experience in the trade, working in the domestic setting and in the commercial settings, hospitals, sporting venues, restaurants. So, firstly, what is a heat pump? A heat pump is a form of renewable technology. So that is that we can use readily available sources to generate heat and electricity we can use in our homes. There's two main types of heat pumps. The first being the ground source, which Dave dived into a little bit earlier. We have a series of pipes that are laid down on the floor to collect heat. Usually below ground is between 10 and 12 degrees, so there's always heat in the ground we can use. But often we don't have that much space. We can use what's called a borehole. Same principle, but it's dived into the ground as opposed to ripping up your whole garden. The main one we're going to talk about today is an air source heat pump. This uses readily available heat in the air down to minus 20 degrees to generate heat for our hot water and our radiators and underfloor heating. So it does this, the air is drawn in through an air intake here over a network of pipes that are filled with something called refrigerant gas. So this is a bit technical, this is how a heat pump works, but it's quite relevant to understand this process in regard to heat pumps. So like I said, we have that liquid, that refrigerant liquid. The outside air is enough to start that process of boiling it into a gas. Once it's started to turn into a gas, it's then passed on to what we call a compressor. This takes the gas that's generated from the outside, squeezes it down even further to heat it even more. Like if you had a bicycle pump, you pumped it, you held the end of the pump, that's actually hotter, isn't it? Because that air is being compressed down. Once it does this and it's ready to be used in our homes, it's passed through something what's called a plate heat exchanger. So here and here, we would have our pipes from the refrigerant, the outside pipes, and here, we would have our pipes from indoors, which we use for our radiators, underfloor heating, and to heat our hot water. The heat is transferred across this heat exchanger, and therefore we can use it indoors. Once the heat has been lost through the plate heat exchanger from the refrigerant side, it's passed back through to a condenser which rapidly cools that refrigerant, turning it back into a liquid, and therefore the process can be started again. That's about as technical as it's going to get, I know, but you have to sort of understand to a certain extent. So that's what makes the heat pump efficient, because we're not burning the fossil fuel like gas, we're just using readily available heat to transfer from one place to another place. So from outside to indoors. So as Dave was talking about kilowatts earlier, the unit of power. So if we still need something to start the process. So if we put 1 kilowatt of power into an air source heat pump, we can generate between 3 and 5 kilowatts out of usable energy for our heating and hot water. So this is a recent project we've done. If we can see the red line here, this is a sort of annual running cost of a heat pump. We've got the years here, annual costs. So this was opposed to a very inefficient gas system, which was costing over £4,000 a year to heat this property. Once we calculate the size of the heat pump they will need, if you can see here, they've effectively halved the running costs just by using renewable. So this is all done through designing a system correctly. So there's 4 key points. So designing to MCS standard, which I believe you sort of have a bit of an idea about, understanding U values, correctly sizing emitters, and the location of a heat pump in regards to your property. So MCS is the Micro Generation Certification Scheme, which is like gas safety for boilers. It's the scheme that we all adhere to, all the rules and regulations of how to install these products. So you have to be a member of that to be able to install these products. And there's all sorts of government funding available, which we will get onto a bit later. But if you wanted access to that government funding, the installer would need to be part of this scheme. So the next point is understanding U value. So U value is thermal transmittance. That's how much an object can retain heat. So if it's a window, a door, a wall, any object. So if we can see here, this is just a brick wall, and the heat is passing out pretty steadily. If we was to add some sort of insulation to the wall, the heat is coming out, the property, the wall is holding its heat more, therefore there is less thermal transmittance, giving it a lower U value. So this is quite a clear image. We've got heat in our homes, it's passing out through here. If we had a higher U value, the heat would go straight out and it's melting the snow on the roof because the building's not being able to retain its heat. But if you increase your insulation levels, lowering the U value of something, the heat doesn't come out as much from the snow. It's just quite clear visual understanding. So we can gather all that information about your property through what's called an EPC, an Energy Performance Certificate. So if we can see here, the property down in Brighton, actually my dad's house. You get all information about what his property is made up of. This is a bit, he's actually got a heat pump now. Obviously. Yeah. So all this information here can tell us, we can put that into a computer program and it tells us the U values of all these different things to understand how much a heat pump would work in your property. So that leads me on to heat pumps in insulation. So as Dave was saying earlier, we're operating at these lower flow temperatures, which is what makes a heat pump efficient. So to be able to use them lower flow temperatures, we need to be able to retain heat better in our properties. So this is through wall insulation, loft insulation. You might have single glazed windows as opposed to like double glazed would be better, because it would have that lower U value. So because we're operating at these lower flow temperatures, we have to design the system to that. So this is called a heat loss calculation. This is something that any MCS accredited installer should be doing. This is how we size a heat pump for your property. So if we just go through, so we've got a living room, we want to heat it to 21 degrees. This is the size of that room, and this is how much power per square metre we would need to heat that property, giving us a total figure here. If we was to add all of them up, go through room by room, remember we're just at the lower flow temperatures, which will give us a figure here, so 3027 watts, which would equate to 3 kilowatts. Therefore, we would need to size a heat pump that is bigger than that, so it might be a 3.5 kilowatt heat pump. Whereas a lot of gas boilers are 28, 24 kilowatts, aren't they? So you don't need to size them that big if you design it properly. Which leads me on to correctly sized emitters. Because we're operating at them lower flow temperatures, we need to have the same output in a room. So you might hear stuff that, oh no, I'm not getting a heat pump because I've got massive, gigantic radiators. You may have to upgrade your radiators to a certain extent, but they might go from what's called a single panel radiator to a double panel radiator, so they might just stick out a bit further off the wall. So the best way to have the most surface area you can is with underfloor heating. So a heat pump and underfloor heating work really well together, but that doesn't mean to say if you haven't got underfloor heating you can't have a heat pump. You just may need to upgrade some radiators to have that same surface area that you did with a gas boiler at 70, 80 degrees. So we have the location of the heat pump. Because we're pulling in outside air, we need to have enough clearance behind the unit to allow that process to happen. And like we spoke about the refrigerant cycle earlier, once that heat is used up in the air, we need to expel that air that's been used, like a byproduct, and that's blown out the front, like an air conditioning unit. Heat pumps, like the same sort of principles in air conditioning unit, we're blowing that cold air out. But we need to have enough space in front of it to blow that cold air out. If we don't, it might bounce back from the object that's too close and get recirculated. And bearing in mind, the heat has already been stripped out of the air, that makes the heat pump less efficient for recycling the byproduct. But we don't always have room to put a heat pump in our garden if you might live in a flat or have limited garden space. So we can install what's called a split system. Remember the refrigerant cycle. So in a split system, half the components are in the outdoor unit, like this, it's a bit smaller, and half the components are in an indoor unit, which may look like one of these here. So heat pumps effectively can be put anywhere with the correct bit of planning and things. So, why would you invest in a heat pump? I spoke about at the start, we've got all these government targets that may take a few years to achieve, but a heat pump is a form of green energy, so we've got less of a carbon footprint and we're helping the government hit their target. Because of the government targets, there is funding available. There's the boiler upgrade scheme, which you can see you get £5,000 off of an installation fee. Remember I said it's got to be done by an accredited installer, but you can see £5,000 off the installation fee. And all renewables are 0% VAT rated. So if you were to get a new gas boiler installed, you'd be paying 20% VAT, whereas renewables are 0% VAT, so that's another saving. So this is diving into some figures just from average costs. So average boiler and cylinder cost, 6,200 plus VAT, 20%, 7,440. So the heat pump, yes, it is a little bit more expensive. It's a new technology, it's more expensive. That's 13,500. But remember, we've got that government funding, so we can take £5,000 off of that, 8,500. So a heat pump, yes, it is going to cost you £1,100 more, but with average energy bills rising, having a heat pump could save you approximately £450 a year on your bills. Additionally, you don't need your gas meter, so you can get rid of paying a standing charge of gas, another saving of £102.20 a year. Combined gives you a saving of £552.20. So in 2 years, you'll be saving £1,104.40, which is more than the additional upfront cost you would need to have the heat pump installed. So in 5 years' time, you're effectively making money on your new renewable system opposed to a gas boiler. And these savings are only going to get even better because, yes, gas and electric prices are going up, but at the rate we are seeing gas increase by, this is overtaking the rate that electric is being increased by. So therefore, there'll become a point when it's actually more expensive to buy a kilowatt of gas as opposed to a kilowatt of electricity. Again, you're going to save even more money. So this is just like what a typical installation of a heat pump may look like. It's actually one we done. So we've got our outdoor unit, and then we have our indoor unit, and this is all the components you would need to have a heat pump installed. Not too much space needed. If you've already got a cylinder in your house, then it can just be replaced, so you wouldn't have to lose any more space in your house.
Excuse me.
Yeah.
Just so that we can get an idea of scale. How powerful is that heat pump?
This one here,
Yeah.
9 kilowatts. So that would be for a 150 square metre house. So what's that? So but this house here is 3 bedrooms and a kitchen and 2 bathrooms, I think, and a lounge. Which is about 150 square metres. So what's that in foot? That's 1,800 square foot. Roughly. It's a big house, but the heat pump's not that big.
Yeah, that's what I'm saying.
So yeah, like I said earlier, when you size, actually do some sizing, we've been used to putting 30 kilowatt boilers in just because you can go and buy one and it works. If you actually worked out the heat loss of your home, you could have a 9 kilowatt heat pump.
Yeah, I have a question about the right hand side.
Yeah.
How big is that? It looks like half a room.
So that is in there. In there. So that's just so that gap's probably 1.2 meters wide, and it's just under 2 meters high. So it's a little bit bigger than a traditional cylinder, but if you speak to us after, I'm sure we can find a place. In certain circumstances, yes, your cylinder might be what's called heat pump ready, but obviously I wouldn't know off the top of my head if it was this or not.
What's the refrigerant that they use in the heat pump?
Various types of refrigerant, R32 refrigerant, R4 10A. They just have different efficiency ratings. Different manufacturers use different types of refrigerant.
What's the lowest outside temperature that it can work at?
Minus 15. So if it gets colder than that, then I won't be coming up. Figure it out anyway.
How do they compare with air conditioning? Because I'm from Greece, so we have one air condition in every room, and it gives heat and it gives,
Yes.
cool
Yeah.
air in stuff.
So you could have an air conditioning installed, but with a heat pump, it's working with efficiency.
No, but I'm saying, would it be better to put an air condition in each room? Would it be cheaper?
Well, if traditionally houses already have radiators installed in them, so we're putting this newer technology onto the older technology. If your house had all air conditioning in every room, then yeah, probably would be better to.
But you wouldn't do hot water.
No, yeah. An air conditioning machine wouldn't be able to heat your hot water.
You can have an electric boiler and switch it on.
You can, but then that will cost more money to run than having a heat pump.
So overall, you think it's cheaper to have a heat pump?
As opposed to air conditioning and an electric boiler. Yeah, without question, definitely.
Good question, isn't it?
Yeah, sorry.
I was just gonna add, I do energy modeling and air-to-air heat pumps, which is what that is, are about 4 times more expensive to run than an air.
Yeah, exactly. Yeah,
Yeah, so
Yeah.
you've got an immediate saving in the beginning,
yeah.
but then you're paying for it
Well,
very much in your bills.
yeah, because an air conditioning would be cheaper to buy, but you would be paying for that cost in the long run because your bill would be more expensive.
Great. Plus there's no fire.
Yeah, and then air conditioning you wouldn't be eligible for the boiler upgrade scheme.
Thank you very much. Oh,
So have you finished your talk?
yeah.
I have, that's fine. Fire away.
Just wondering how easy, when you're replacing combi boilers, you that cylinder.
Yeah.
How structurally easy is it to fit a cylinder in a house that doesn't have one already?
Well, cylinders, you can get a horizontal cylinder, which you can put in your loft, and it lays down, or you would need to find some sort of space. Where the combi boiler is, typically in a kitchen, might be in a larder unit, you could take it out and then put the cylinder in there.
This is getting right. We'll start at the back. Yeah.
Thank you. Can you tell me about the noise levels of the heat pump?
Yeah, so the noise of a heat pump, they're quieter than a conversation, and it's like a fridge would sound indoors. 54 decibels is the MCS requirement to have a heat pump, so that is quieter than a conversation we're having now.
Is that just outside there, or is that?
That's just outside, yeah. So you can sight it away from a bedroom window, but the technology nowadays, you can barely.
From that, yeah.
You quoted a price of 13,000 something pounds for an installation. One of the themes of these talks is retrofit, and
Yeah.
I've been investigating retrofitting into a 1860s terraced house,
Mhm.
the chart, yes, the headline price is 13,500, but then when you look afterwards, there's the installer saying, oh yes, but you have to pay for taking up the floorboards to put in the pipe. You have to pay for the changes to the cupboard where you put in the boiler. You have to pay to take the bath out and put it back in to get the pipes underneath. You have to pay for the preparation of the site and making the base, which takes the price over 20,000. And that involves you finding another contractor and supervising them to do the work to the standards that the installer wants. Is that price taking those kind of things into consideration? Or are we talking about a simple
You're
A simple
paying
example.
for a lot of stuff. So, yeah, I mean, without going into how we structure a price too much, every job being different, initially, if your house, you were retrofitting it, what did you say,
1860s?
1860, maybe your first instance, you would put some of the money into insulating your house. And then in 5 years' time, your home might be more suitable for a heat pump if you initially put the money into that. That would be my suggestion.
What are you
Yes,
doing
but
Thursday?
there's lots of other work which needs doing to put the pipes in, to put the heat pump outside
Yeah.
in the base.
So
Is that
Thursday
included in
evening
the
at the
price?
Velodrome, it's retrofitting very old houses.
Yes.
That's the topic on Thursday.
So is that a realistic price for retrofitting a very old house?
Yes.
In terms of,
Well, I don't know who you're getting to do it, so I might not know that much.
so we had some questions over here. I'll come to you.
Can it make any sense to add the heat pump to the conduit boiler?
Yeah, you can certainly do that. That's called a hybrid system. Didn't really touch on it too much here. But you can incorporate a heat pump with a existing gas boiler, but the only downside of that is you wouldn't be eligible for the grant. To be eligible for the grant, the heat pump has to cover the whole heating load 24/7.
What about cooking on gas? You actually have to have meat.
Oh, no, you don't, but that's just to give you an idea.
No,
of
no,
the
sorry,
same.
somebody else had told me I had to have my gas.
No, yeah, if you like cooking on gas, you
It's just saving 100 quid if you don't have to.
Yeah.
yeah, I'm just saying there is no need to have the gas if you don't.
Gentlemen,
I live in a house with 4 flats. It's practical to have one heat pump. Heating all 4 flats.
Yeah, you can do that, but it becomes a bit tricky with planning and who's paying for what.
Yeah.
But you can have communal heat pumps, so they're bigger, more of like a commercial unit, and then each property has a smaller unit inside, and the heat that you use is measured.
So I was thinking, is it more efficient to use ground source or air?
Ground source heat pumps are slightly more efficient, but then the uptaking cost is so 13,500 for air source. The ground source, one of them holes is £8,000 to do one hole. So you're looking at about 3 times the cost. But yes, they are more efficient.
Thinking if you're sharing.
Yeah.
do you get on well with your neighbours? Freehold, okay, good.
Yeah, so if you're to have them conversations, but we've had this before with blocks of flats, and it does get a bit tricky with who's paying for who. Do you see what I mean? Yeah.
Claire, that's flat without their pigment.
Hi.
So,
So it obviously heats the house.
Yeah.
but It also heats the water.
Yeah, through the hot water cylinder. So that would just be like how a normal water cylinder would work. There'd be a pipe running through the cylinder that goes like this, and comes back out, and the heat that we use from the heat pump, the water goes through that pipe and transfers the heat from that pipe to the hot water cylinder.
Yeah. So if you've got a house of 4 people, 2 teenagers who like to shower a lot, that would be sufficient because we've got a mega flow as well. So
Yeah.
would you need a mega flow too?
A mega flow is just like the brand of cylinder. But the cylinders come in different sizes. So typically, 2 people might need stored 180 litres of water, but if you've got too many teenagers, it's like, you might need 300 litres of stored water.
Yeah, brilliant. Cheers.
So what temperature would the hot water be?
The hot water is at 50 degrees, between 50 and 55 degrees. But you don't shower in anything more than 40, 42 degrees. So why do we, when we have a gas boiler, we heat it to 70 degrees, which is, again, not efficient. Regardless, if you have a heat pump installed, you still turn that down. There's no need to heat water to 70 degrees.
Just a thought. You said the heat pump kicks out cold air.
Yeah.
Having just lived through a 40-degree summer, is there any technology that can take that and blow it into the house when it's really hot?
No.
Just checking.
No, but
Where you put your deck chair.
you can. I mean, this is diving into it a little bit deeper now. You can get radiators that can do cooling as well, so they can take about 2-3 degrees out of the temperature of the room through the radiator. So working in opposite.
Jane.
Yeah, if you're blasting out cold air and you put the air source heat on the side of the turn, and it's within sort of, I don't know, 6 feet of your neighbours, you can be shoving cold air into their flat and getting complaints.
To a heat pump to MCS standard, it has to be a metre away from the neighbour's boundary. So if you're complying with that regulation, you're not.
It's not going to.
No,
they're not going to fill
no.
the hot
The
air.
the air will blow cold for about 700 mil, and then after that it will. So if you were a metre away, that's why they say a metre. It's not going to be as cold.
What do you do if it can't be a mutual right?
Then you put it somewhere else. Oh well. Come and talk to me after if you. I mean, you can hang them on walls. You can put them on a flat roof of a garage. Some heat pumps you can put right down the end of the garden. Yes, you would have to dig a massive trench to get to a house, but there's always a way that you
Is
can.
that just permitted development though? Because the implication of earlier in the week was that you could have it within a metre if you got planning permission. So the 1 metre point was more to do with whether or not you needed planning permission, not that just you were not allowed to do it.
Yeah, sorry, that is right. You can if you get planning.
That's
So
what we learned
On,
earlier in the
on
week.
Monday.
Yeah.
yeah, no,
Monday's class.
that is correct. Yeah.
Okay. Yeah.
You can get heat pumps that generate higher heat output that are being used in Scandinavia, the Alps, for example.
Yeah.
Why are they not being promoted?
Because our houses aren't as well insulated as them generally, and the way we use our heat, it's not as efficient to do that. You can do that, but you need electrical assistance as well to get it up to that higher temperature. Basically, the higher flow temperature, the less efficient a unit is. And yes, there is units that do that, but they're not as efficient.
What sort of efficiencies do they run at?
So we're between 2 and 3, which is still, that is efficient, but if you're having one installed, you want to be looking at them 4 to 5 numbers. That's when you really start to get savings.